Sure.
If you would prefer to refer them down, tell them that right now. And then just do that.
Okay. All right. Welcome back, everyone. As Dave said, my name is Robert Reichel, and I've spent the last 4 glorious years working for Jim Kelly. And one of the things that I needed to do was to interact with groups like the NTFS group and the NET group and some of the other organizations on the NT project and sort of explain to them what we did and what they need to know and what they don't need to know. And so I'll sort of tell you roughly the same things that I told them. The good news is you don't really need to know everything that Jim went through in the last hour. It's great and it's really fascinating stuff, but you don't have to know all of it. The things that I'm going to go through are more what's visible to you as a file system writer, what are the things that you really need to pay attention to, and what are the things that you get to completely ignore. So ultimately, it's a good idea to make sure that you have a real understanding of what's going on, but it's not necessary that you know exactly what bit goes where and which access mask and everything like that. And if you find that you need that kind of information, you might want to take a step back and look at what you're doing and maybe sort of reconsider, make your life easier on yourself. You have 3 things that you need to do as a file system writer. You need to store and fetch security descriptors such that they come back in roughly the same format that they got written. You need to call access validation routines, and I'll talk to you about what those are and how you call them and how you don't call them. And you need to perform auditing. I provide services for pretty much all of these, so it's just a matter of getting the right set of things in the right order. Now, it's a little bit of recap on what Jim talked about. This is the big picture. You have a subject. The subject is a person. The person could have just walked up to the computer and logged on. The person can be coming over a net, but ultimately there is a person there, and the person is represented by a token. The person is in groups. The person has certain security attributes. The person wants some set of accesses on a resource. In this case, most people here are probably concerned about files. All the stuff I'm going to be talking about is general to the NT system, right? From my point of view, a file is just another object. And you can protect processes, threads, semaphores. All the objects in the NT system use these same mechanisms. So occasionally something might look a little squirrely in some of the interfaces, and a lot of that squirreliness is there for the benefit of supporting other kinds of objects, and things might not actually apply to files. So, but this is really the situation we're talking about. User comes up, any user, wherever you want, Paul or James, comes up, says, I want to access, nuclearsecrets.txt. I want to type it up, and the file system gets to decide if this is something that it wants to allow based on the security descriptor. Typical open request involves getting back the security descriptor, calling SE access check, recording the results of the SE access check call in the access state structure, which Jim alluded to in his discussion, call auditing routines, and then go do something else. And that's, excuse me, I'm a slide behind. So those are the steps that you really have to worry about. Access validation is typically performed in the parse method. By the way, I hope everybody is using the set of slides that were handed out separately. If you're using what is in the book, it will eventually not look the same as what I'm talking about up here. So you should have gotten a separate set of packet of slides. Access validation typically happens in the parse method, where you're doing name resolution. You're actually trying to find out which file it is the person is referring to. And you get the file, and that's when you're going to decide if you want to satisfy this open request. An access state structure will be passed to you in the create ERP. And that's about the grand extent of what I know about create ERPs, is that you're going to get an access state structure in one of them. The access state structure has a lot of things in it. I'll show you the actual structure, and I'll tell you what's important in it and what isn't. If the world were perfect and we were all using cool object-oriented languages, there would be a public section and a private section, and you'd know better than to stray into the private section. As it is, you just sort of need to know what fields are of interest to you and what fields are of interest to me as the rest of the security system. The main fields that you're interested in the access state are the remaining desired access field, which is the list of all access bits that have not been granted at the point that you get this thing. Previously granted access is the list of accesses that have already been granted. And there's a bit called generate on close, which is relevant to auditing, and I'll show you how that's used. Everything else, for the most part, you're never going to look at. Some of them are there for reference. Some of it doesn't hurt to look at. You should be careful about changing anything else. The previously granted access holds bits that were granted by other parts of the system. And the idea is that an access validation is not necessarily an atomic operation. Right? You can have, and this is going to start getting into policy, but an access validation can be a multi-phase operation. If the subject wants 5 bits of access to that file, each of those bits could, in theory, be granted in a different way. And in fact, you might not even end up looking at the security descriptor to grant those bits. It's up to you, and it's really your policy. Now, some policies are better than others, and we implement some for you. But that's why we have to keep a record at every step along the way, what's been granted and what still is remaining to be granted. A lot of this will be clearer when I go through the code example. We're going to walk through part of how NTFS does all of this. The heart of access validation on NT is SE access check. And it takes a large number of parameters, most of which are pretty straightforward. The important thing to remember about SE access check is that calling it does not in any way change the state of the system. Right? We don't remember that you called it. We don't make any permanent marks anywhere that you called it. It doesn't generate an audit. It doesn't make the system crash. It doesn't do much of anything. It just gives you a set of information back. And you can call it as often as you want to get the information that you need. And what you pass in, we'll massage it. We will look at it in a set of well-defined kind of ways, and we'll pass you back an answer. And what you'll see is that NTFS will call SE access check any number of times as part of determining whether or not a file should be open. And Jim sort of talked about what and why they do that. I'll go into a little more detail. The first parameter you see is just the security descriptor, which in theory you know where that is. The subject security context, which you're just going to get out of the access state. You don't need to go capture it or anything like that. And it's a good idea to use the one out of the access state, because if you're doing the access check in a different thread from where the user was when he or she issued the open request, you want to use the one that gets passed to you in the access state so that you get the correct context. Right? There's no rule that says you need to do this in the thread that the actual open came in. So you want to use the subject context that we pass you. The subject context needs to be locked before it's looked at in here, and locking it may be an expensive operation. If you're going to call this thing multiple times, you want to lock it once, pass in true for the third parameter, and that saves the overhead of lock, unlock, lock, unlock. Lock basically just means reference the token objects. And if they've been paged out or something like that, you have all sorts of problems. The desired access is what still remains. It's the remaining desired access. It's what's left. It's the reason why we're calling SE access check. Previously granted access is sort of optional. We only pass it in so that we can combine it with what you get from the desired access and pass you back a complete mask at the end. You'll see in one situation NTFS doesn't bother even passing that in at all. So if you know what it's for, you don't have to really worry about it. Privilege set, the reason why you have to pass in a pointer to a privilege set is because SE access check will implement some policy. So for example, if the user wants to open up a file for right owner, the user can either get right owner from the ACL or by virtue of having a privilege, by virtue of having a user right. If we do a privilege check and say, yea, verily, this privilege is in the token, and this privilege was used to grant that bit, we're going to return a privilege set there. The reason that that's interesting is because that then needs to be passed into the audit routine later on, so that we can say in the audit record, this privilege was used for this access. And this will come out just as a privilege set. You take it, you glue it onto the access state with a well understood routine, and then you just free it when you're finished. So it's very straightforward. The generic mapping is a structure that Jim Kelly talked about before, which maps generic all to some set of bits, generic right to right bits, etc. Since we're presumably dealing with files here, everyone's going to be using the same one, and that's pretty easy to find in the system. If you're dealing with other kinds of objects, you would pass in the generic mapping for whatever object you are operating on. The access mode is either user mode or kernel mode. It's the previous mode. NTFS will have to jump through some hoops to figure out what that was. In most of their situations, if they just call get previous mode, they're going to find out that the previous mode is kernel mode, and the access is going to go through. The kernel is never denied anything. So it pays to compute, say, well, I really want to do an access check here, and I really want the system to look at the security descriptor and figure out whether the user had access. And if you pass in kernel mode there, you're going to get pretty much anything you ask for. So there are some situations when you want to do that. They're pretty rare, but they exist. You get out and a granted access mask. This is really what SE Access Check did, is compute a granted access mask. And it may look nothing at all like what you passed in. And that's really the work of what SE Access Check does, is computing that mask. So you can't assume that you're going to know what that thing looks like based on what goes in. If the user asks for maximum allowed access, then SE Access Check will go through an algorithm and compute what that mask really is. And lastly, it's going to return a status. You notice that SE Access Check itself just returns a Boolean. If that fails, you need to return the access status that I give you back. If you just turn around and return access denied, you're broken, because in some later versions of the system, if we go to a higher security level, mandatory access control, B1 level, we may need to return different return statuses depending on your compartment and all that other kind of noise. So return the status code that on failure that SE Access returns, and don't assume that you can figure out what it's going to be. Once you call this, nothing has really happened. You've just gotten some information back. You need to shove some bits from the remaining desired access mask into the previously granted mask in the access state. And that records for that particular access request really what happened. You sort of need to tell us what it was. If you got back privileges, you're going to call SE append privileges, access state privileges, put them together, free what you got back from SE Access Check. And if access check fails, again, just return what you got. And the next thing, before you're finished, is auditing. To perform auditing, you're going to call SE Open Object Audit Alarm. Excuse me. SE Open Object Audit Alarm is actually going to generate an audit. And you really need to call it once when you're finished, unless you want lots of little audits of your progress in the log. And that's normally not what users want to see. So typically, regardless of what kind of machinations you went through to grant access to the file, you'll make one auditing call at the end saying, here's what was asked for, here's what they got, did it work, here are the privileges that were used. And if you have to do 10 access checks to do that, typically you won't want to generate 10 audits. You'll just generate one. Parameters are pretty straightforward. There's an object type name, most logically file, right? A pointer to the object, which is optional. You guys don't have a pointer to the object at the time that you're going to be making this call. You don't need to pass that in. There's an absolute object name. You are going to need to pass that in, because there's no other way for me to figure out what the name of the object is. And that should be a fully qualified name of the file. If you just say, foo.txt, that doesn't tell the user a whole lot about which file it is. So pass them a fully qualified path name, and later on in the auditing system, I'm going to attempt to substitute a drive letter if I can. So you need to pass in as much information as you can. Same security descriptor as before, the access state, with all your nice little bits pushed around in it. Whether the object was created or opened, mostly opened. We don't typically audit creates in NT. Whether the access was granted or not, yay, nay, you still have to call this if the access didn't work. Previous mode, same thing as before. It should be user mode if this is really in response to a user request. And then the generate on close flag. You're going to just stuff that back into the access state. The purpose of the generate on close flag is that when the handle is eventually closed, we need to generate a close audit. And so you record this value in the access state. It gets stuffed away with the handle in the object manager. Handle gets closed. We see this flag. We generate a close audit. You don't have to worry about that. The object manager will take care of that. And the grand and glorious access state. As I said, most of this you really don't have to worry about. There's the remaining desired access field, previously granted access. There's an original desired access field, which the auditing system will use. That's an exact picture of what the user passed in at the beginning. You can see that there's a subject security context there. There's also a security descriptor. You should never be looking at that. That's for another part of the object creation path. You're a file system. You know where your security descriptors are. You shouldn't be looking in the access state for it. And some other things that are used as part of the auditing system. So it's just a repository, and it's to keep every SE level call from having this many parameters. So that would be pretty unmanageable. We kind of glop them all together into one big structure and decide to tell people how to use it. The other thing you need to do is maintain security descriptors. There's opaque, from a file system point of view, they are opaque. You don't have to pull them apart. You don't have to look at what's in them. You don't have to think very hard about them at all. It's just a big glob of data. And you just need to be able to fetch it back in some semblance of how it went out. If you're worried about space, you don't want to store lots of security descriptors around. I don't care if you really pull the things apart and you cache ACLs here and owners here and pointers, whatever. You just need to be able to reconstruct one in a format that I understand when it's needed. So different file systems might decide to play different games about how they store these. It doesn't really matter to me. So you can make as much work for yourself as you want. And you can use the SE routines to manipulate the internals. So you can get into as much detail as you want about ripping out the DACL and seeing who the owner is and all that other kind of stuff. There are two formats for security descriptors. There's absolute format, which contains pointers. Typically, this is what the user passes in. If you construct a security descriptor with 132 level calls, you'll get an absolute format security descriptor. A structure with pointers is not particularly useful if you're a file system. So there's another format of security descriptor called self-relative, or a marshaled format for those of you familiar with RPC nomenclature. And the self-relative security descriptor is suitable for permanent storage. All of the SE routines can take either, but there isn't really any reason for you to ever be passing around absolute format security descriptors. I can't think of any reason why that would ever happen. There are 4 options that can be passed in the security method for files. The user can either, well, the first thing that typically happens is security will be assigned to a file. This is different from, we make the distinction between assigning and setting. Assigning means this is a new file, this is a new security descriptor, put them together for the first time. You do this by calling SE assign security, typically passing in the user's security descriptor the user wants to put on the file, the parent security descriptor if you have it, so like its container security descriptor. And out the bottom of this will come a self-relative format security descriptor suitable for mass storage. So you call this, you get something out, you're pretty much done. The user may want to, later on, after this file's been around for a while, change the security on the file. You'll need to fetch the security descriptor, take what the user passes in, call SE set security descriptor info. I will do all the hard stuff. You take the result, put it back on the disk. Query, pretty straightforward. The user wants to see a piece, call me, I'll pull it apart for you. You get to return what's left to the user, and you'll be told that you don't have to keep the security descriptor around anymore. And since it's in your storage, you get to delete it in whatever manner you see fit. And those are pretty much all the things that you're going to ever need to do to a security descriptor. Policy. Policy is an interesting topic. One of the mantras for NT is that the NT executive tries very hard not to enforce any kind of a policy either on file system writers, subsystem writers, you name it. So the executive is not necessarily going to make you do any particular thing relative to security. So I'll talk about, and Jim mentioned before, and I'll go into a little more detail now, about NT NTFS's security policy and how they implement it. You can make your policy, as wacky as you want. Whether it will actually be a usable file system or not is entirely up to you. But if you want to grant access to files based on phases of the moon, you're perfectly welcome to do that. No one will enjoy using your file system, but you can. What NTFS did was they said files are considered attributes of their containing directories, meaning if you have access to a directory, you have implicit access to the files that are contained in that directory. That's a policy decision. They could have done any number of things, but it was decided that if you have access to a directory and you can do a dir on it, you should be able to see things like the sizes of the files that are in that directory. So you have enough access to the files in that directory to say, what are your attributes? That's basically it. You also have delete access to files in your directory, which means that if you have no access whatsoever to the actual file and you have access to its directory, you can still delete that file. Right? And this is not a bug, despite how many times it's been reported to me as such. This is a feature. So, fine line. So, we're going to talk about NTFS access check policy. I just talked about the policy. And it will require multiple access checks. And there's some code, which in theory you all have. Line numbers down the side. This won't compile if you were to take it home and type it in. I cleaned it up by removing all the local variables and things like that. So it wouldn't last very long if you actually tried to execute it. But I tried to leave everything that I considered interesting. It starts off with a pretty normal set of parameters. Next slide. Right. An ERP context, that's an NTFS specific structure. I don't know what's in it. An FCB, which is going to contain the, in this case, security descriptor. The parent FCB, which they may or may not pass in the ERP. The access mask, desired access, which in this case duplicates some of the things found in the access state structure, and a check-only flag. And NTFS will call this routine for several different reasons and in several different contexts. And sometimes they just want to see if the user has access to something. They're going to just say, which is really what the check-only flag is for. It says that there isn't really an open going on. We're just going to look to see what access the user has. Pushing down, 1 second. I created crib notes for myself with line numbers. Okay. Pushing down to about lines 68 to 85, we see the first call to SE access check. And you see, first thing that they do is they lock the subject context. SE lock subject context, and that means that they never have to worry about that again. They do need to unlock it at the end. If you forget to do that, that user can never log off the system, so it's pretty important to do. They call SE access check. They pass in the security descriptor. They pass in the subject context from the access state. Yes, tokens are locked. They pass in true. They pass in their desired access. And they pass in 0 for the previously granted access because it didn't really matter to them what they do at this point. They're going to just combine everything at the end anyway. They pass in a pointer to the privileges, which may or may not get filled in. They pass in the generic mapping for files. And then they pass in a really hellacious line where they use to compute whether this is really an access check going on. And you'll notice that there's a flag that they check in the ERP to say whether or not to actually force an access check or just take whatever the previous mode was. If that bit is set, they just explicitly pass in user mode. And that bit is normally set, it turns out. Point you to a grant access mask, they'll get bits back, and the access status, which they're going to return if this fails. That's the straight, simple, easy to understand. We got some bits. We're going to want to look at the security descriptor. Do we get the bits? Things get real more complicated if they don't get all the bits, in which case this is going to fail, or the user is asking for maximum allowed, and they don't get all the bits. Because now they have to say, okay, we're going to ignore this result for a little while. Now we have to start looking at containing directories to go implement our very cool policy. Down about lines 99, we see they take what comes out of this, and if it worked, in this particular case, if SE access check worked, they take granted access, they orient it to previously granted access. Good, that's the right thing to do. And then they say, if maximum allowed was requested, they need to keep track of that for later. So if maximum allowed was requested, they can't just look at the security descriptor, because that won't give them everything that they need. If maximum allowed was requested, they need to look at the parent. So now they're going to go back and they're going to say, you know, if delete was requested, they're going to keep track of this. If file read attributes was requested, they're going to keep track of that too, so that they can check for it later on. Down about line 163, the user is asking for delete access. Check if the parent will grant delete access to the file, and if so, we can munge the desired access. That's a technical term. If delete is on in the desired access mask, or we need delete because they asked for maximum allowed, we're going to call SE access check again. And if you look at the fourth parameter, you can see that they're just passing in a hardwired file delete child, because that's really all that they're looking for at this point. So, and this will, since it doesn't maintain any state, they can just do as much of this stuff they want. They're going to say, okay, Mr. Parent, do I have delete access? And that's what this call will do. If you notice, the first parameter, they're passing in the security descriptor from the parent FCB, not from the child. So they're just looking at data structures and trying to figure out what's what for this access request. This is for delete child, and the next one, the next slide, is for read attributes. They have to do the exact same computation to see if they're going to get read attributes from the parent. So, trucking right along, down to line 249, what they've done is they've said, all right, the first call to SE access check failed. It failed because we didn't get all the bits. We just granted 2 bits by looking at the parent. Okay? Take those bits out of the desired access mask and see if they were the ones that caused us to fail the first time. Right? Because either of those, you might have been missing delete, you might have been missing read attributes. We just got them from somewhere else. Remove them, try again. This one may or may not work. So you have to see if now that you take those out, if you can get everything else that you were looking for. So now they're going to look at the child again. They get the security descriptor from the FCB, subject security context, pass in the desired access, which they've removed a couple of bits from, and they're just going to see what happens. And proceeding down, last few interesting lines are lines 273 to 293. Last bit of maximum allowed messing around. If they asked for maximum allowed and we got anything at all from any source, then we need to return what we got. Remember, maximum allowed will succeed, a maximum allowed request will succeed if anything is granted. And frankly, nobody really cares whether it came from the object or the parent. So if they got anything, then return it. There's a little bit of, there's a special case for maximum allowed where if you pass in, and Jim mentioned this briefly, if you pass in maximum allowed in conjunction with any other bit, that means give me everything I can, but if this bit is not set, fail the entire request. To preserve those semantics, they have to see if the desired access is exactly equal to maximum allowed at this point before they can go and return what they got. Otherwise, they have to see, to preserve the semantics, they can't just go blindly returning what came out of SE access check. that's pretty much it for access checking. Next, they have to do some auditing. There's a shortcut that file system can call to see one thing and one thing only, is auditing on 4 files. This won't tell you whether this particular file or this particular open is going to be audited. It just says, okay, system, tell me, is there a chance this is going to be audited? If this returns yes, then you need to proceed with the audit call. And this is as clever as you're allowed to get for making this decision, because otherwise, you're probably going to get it wrong. And the reason for this is because the setup for the audit call may be expensive. I don't know how your file systems work, but in NTFS, constructing the name information was sufficiently painful that we didn't want to do it just for yucks. So if this returns yes, there's a good chance that an audit is going to occur. Go construct the name information, do everything, and everything will be cool. And finally, we come to a call to SE Open Object Audit Alarm. And it just takes the parameters that we talked about before. The first parameter is pointer to a string, which in this case will probably say file. Pass in null for the object. Full file name, you can see above this call, this is about line 438 code. If you look at about the page and a half of code above this call, you can see what it took to actually put the name together. Pass in file name, pass in the security descriptor for the object, the access state. The false means that the object is being opened and not created. Whether access was granted or not, remember you need to call this even if access is denied, especially if access is denied, because typically that's the interesting case. Whether this was what previous mode should be, however you want to figure that out, and the generate on close bit. And you see that they just pass in the address of the field in the access state structure, and they don't have to worry about it anymore. And this actually generates an audit. So, and you don't have to worry about it anymore. And once this is done, you need to do whatever cleanup you need to do. And that's about it. You're effectively finished. All the information that's relevant is recorded in the access state structure. You return true or proceed however you're going to proceed. If the access has been granted, you return my status code if access was denied. And that's basically all there is to it. This is just an access validation. This is just an attempt to open. NTFS provides the security descriptor. I don't know where it comes from, and it's of no interest to me where they actually get the security descriptor from. So at the point where we enter this routine, the security descriptor is in the FCB, and that's where I come into the picture effectively.
You need to repeat the question.
Oh, I'm sorry. I can hear you.
The access check, the check only flag, what's the difference between setting it and not setting it? What do you do?
That's something that if I had left all of the lines of code in this, what you would have seen is that they use that to decide if they want to make all of these calls. I didn't want to get into exactly when this routine gets called and all of the different things that it can do. So that's an NTFS implementation specific detail is what that flag is for. And it's not, I didn't feel that it was relevant to go into exactly what they're using that for. The only reason it's interesting is to say that you can do information-only access checks without necessarily saying, all right, I am doing an open, I am granting access to a file. That's really all that they're using it for. I can't pull an example out of the top of my head. This is called in about 3 different paths. And it's called through various sets of macros, and a lot of times they just hardwire that thing to true. In fact, it may be true in every time that it's called, but they wanted to keep the interface wide enough to allow more flexibility if they want to call it later. So Brian Andrew would have be the person to really explain, here we zig and here we zag and here's why we're doing this. Yes, sir. Quite finally, those are part of the compiler. Those are done at compile time. A set of exception structures are built up by the compiler because they have to figure out scoping information. I actually implemented this stuff once. They have to figure out scoping information and figure out where you are in the code, and that's something that's done at compile time. I don't think they could possibly be implemented as macros, even if you wanted to. Anyone else? Okay, thank you very much. Enjoy the rest of the conference.